And this question it is given that two conductors having same width and length, thickness d1 and d2, thermal conductivities K1 and K2 are placed one above the other. Find the equivalent thermal conductivity. So in this question, just try to understand what they are trying to say. So two conductors having same width and length. So we can just consider that the length of this conductor is equal to L, and we are having another conductor, but over here take it as in question two conductors having same width. So we can even take their width is also same. Let's say I'm just representing this width by W, and thickness is different. For one we can take it as thickness is D1, and for second one the thickness is D2. So it will look something like this. So just try to understand which parameter over here is different in both the situations. So in the second situation, so we are considering a similar kind of rod which is attached with this one, but the thickness is different, means it is given as nothing but D2. The thermal conductivities are for this one it is given as nothing but K2, and one above the other. One above the other means they are connected in like parallel combination. So the other one is kept something like this, and of same length and different thickness. The other dimensions like width is same. So for this one also width is W, and length we can take it as L, and conductivity is different K2, and its thickness is, let's say, that is equal to D2. So area of cross section over here is different, and the length is same. So it is a common case of a parallel combination, So area of this one, let's say I'm just writing it as A1, which we can take it as W into D1, and area of this one we can take it as nothing but W into D2. Now we can write the equation for K equivalent. We can write the value of K equivalent is nothing but K1 A1 plus, I'm just writing the equation for equivalent conductivity in parallel combination. So this K1 A1 plus K2 A2 divided by A1 plus A2. So you can write over here the value of K1 is nothing but W into D1, and K1 which we can take it as K1 plus K2 into A2, which we can take it as nothing but W into D2 into the value of K equivalent K2 divided by A1 plus A2, which we can take it as W D1 plus W D2. Now we can take this W as common, so we can cancel this W, and the remaining things we can take it as D1 K1 plus D2 K2 divided by D1 plus D2.